Imagine a sphere in space filled with hundreds of thousands of stars, spinning like an ancient swarm around the galaxy. This audiobook invites you to discover globular clusters, formations so old that they may hold clues about the early chapters of the universe. What secrets do these stellar spheres hold, and what can they reveal to us about the hidden origins of the Milky Way? A journey through the forgotten heart of the cosmos, where each star is a piece of the past. Imagine a garden of bright and colourful flowers. Each flower represents a star, and the entire garden is a globular cluster. Unlike a common garden, this one is located in the vastness of space, floating in the darkness of the cosmos. Globular clusters are groups of stars that have remained bound together for billions of years, giving them a special character. They are like time capsules that offer us a unique glimpse into what the universe was like in its earliest stages. These clusters are not just random groupings of stars, they have a spherical shape and are primarily composed of old stars which have lived a long time and gone through various phases of their evolution. They are often considered relics of galaxy formation, making them treasures for astronomers. By studying their composition and behavior, we can unravel the mysteries of star formation and galactic evolution. It is fascinating to think that by observing a globular cluster, we are looking back in time. The stars in these clusters are some of the oldest in the universe. What stories could they tell us if they could speak? Each star in a globular cluster is like a witness to the history of the cosmos, and their study can unveil secrets about how galaxies formed and how they have changed over billions of years. The importance of globular clusters is not limited to their visual beauty or their age. They also play a crucial role in how we understand the structure of the universe. Did you know that these clusters can help us understand dark matter? By observing how they move and distribute themselves in space, scientists can make inferences about the presence of this mysterious matter that we cannot see but which influences gravity and, consequently, galaxy formation. They are often considered natural laboratories where astrophysical processes can be studied in action. When we analyze their characteristics and dynamics, we gain valuable insights into the interaction between visible matter and dark matter. It's as if each globular cluster is an open book about the history of the universe, waiting to be read. Moreover, their study goes beyond the realm of astronomy. Globular clusters have inspired poets, artists, and dreamers throughout history. Their beauty and mystery have been a source of inspiration in culture and mythology, symbolizing not only the grandeur of the cosmos but also our own quest for meaning in the vast universe. As we advance into the era of modern technology and astronomy, interest in globular clusters has grown exponentially. With more powerful telescopes and advanced observational techniques, scientists are uncovering data that helps us better understand these fascinating celestial objects. Each discovery is another brick in the construction of our knowledge of the universe. Ultimately, globular clusters invite us to reflect on our place in the cosmos. They remind us that, although we are small compared to the vastness of the universe, each of us has a role to play in the story of creation. Curiosity drives us to explore, learn, and discover. Just as globular clusters reveal their age and wisdom, we too can seek answers to the questions that trouble us. Throughout this journey through the universe, globular clusters stand as beacons of knowledge, illuminating our path toward a deeper understanding of the nature of the cosmos. In the upcoming sections, we will delve even further into the history and significance of these fascinating objects. But for now, remember that every time you look at the starry sky, you might be seeing not just stars, but also the echoes of a distant time locked in the embrace of a globular cluster. Are you ready to continue exploring these celestial mysteries? Globular clusters are fascinating groupings of stars that seem to float in space like jewels shining in the darkness of the cosmos. But what exactly are they? In simple terms, a globular cluster is a dense and ancient group of stars that orbit around the center of a galaxy. Imagine a sphere filled with twinkling lights where each star is bound together by gravity, creating a dazzling spectacle that tells us about the history of the universe. The shape of these clusters is quite peculiar. They resemble a golf ball, compact and round, but instead of being made of rubber, they are formed by thousands, even millions of stars. Their density is such that inside, the stars are much closer to each other than in other parts of space. Have you ever imagined what it would be like to live in one of those clusters? It would be an environment full of light and activity, where each star shines with its own intensity, and gravity acts as a force that keeps everyone together in a cosmic dance. One of the most intriguing characteristics of globular clusters is that they are very old. It is estimated that many of them are over 10 billion years old, which means they are almost as old as the universe itself. Think about that. These stars have existed for eons, witnessing the evolution of galaxies and the formation of new stars around them. What stories could they tell if they could speak? Each cluster is like a wise old man of space, holding secrets about the cosmic past. As for their composition, globular clusters are primarily made up of old stars and surprisingly contain a very low amount of heavy elements, while in our own galaxy, for example, we are surrounded by stars that contain a variety of more complex elements. Globular clusters are mostly rich in hydrogen and helium. Why is this important? Because it allows us to understand how the first stars formed and how, over time, the universe has become enriched with elements through processes like supernova explosions. Some might wonder if all globular clusters are the same. The answer is a resounding no. Although they all share certain characteristics, there is an incredible variety among them. Some are extremely dense while others are more dispersed. This is due to their unique history and the way they have interacted with their galactic environment. Thus, each cluster is, in a sense, a miniature universe with its own dynamics and evolution. Globular clusters are not only beautiful to behold, they are also key to understanding the structure of galaxies. Imagine that galaxies are like large cities and globular clusters are their oldest and most traditional neighborhoods. By studying these clusters, astronomers can gain clues about how galaxies formed and evolved over time. And what about their distribution? These clusters are often found in the outer regions of galaxies, in a halo surrounding the main galaxy. This is an indication that they may have been some of the first stellar systems to form. As we explore more about globular clusters, we also discover that they are true natural laboratories. Within them, scientists can study stellar dynamics and how stars interact with each other. For example, in a globular cluster, it is common to see stars moving at extremely high speeds, which helps us better understand gravity and the formation of structures in the universe. Have you ever wondered how stars form in such a dense environment? In a globular cluster, stars can merge or even steal material from others, leading to truly interesting phenomena. At the center of many globular clusters, we often find a fascinating mystery: black holes. These dark objects are like the great villains of the universe, and their presence in globular clusters raises intriguing questions about how these clusters form and evolve. Some scientists believe that the interaction between stars in a cluster could facilitate the creation of massive black holes. Thus, globular clusters are not only a home for stars, but may also be the place where some of the most enigmatic black holes are born. The observation of globular clusters has been facilitated by advances in technology. Modern telescopes and satellites have allowed astronomers to study these clusters with an unprecedented level of detail. Through images and collected data, we can explore the structure and composition of these fascinating stellar groups. Can you imagine how exciting it must be to capture the light of a star that has been traveling through space for billions of years? In the end, globular clusters are more than just simple groupings of stars. They are cosmic treasures that offer us a window into the past of the universe. As we continue to investigate and learn about them, each new discovery brings us one step closer to unveiling the secrets of the cosmos. In this journey, we are not only exploring space, but also our own history and place in the vast universe we inhabit. Globular clusters are fascinating structures of the universe, but have you ever wondered how they were discovered and studied throughout history? To understand their history, it is important to travel back in time to the early days of astronomy, when humans began to look at the sky with curiosity. Imagine ancient astronomers observing the stars with their naked eyes. Without telescopes, the vastness of the cosmos was a mystery, and some of those mysteries seemed to be simply groups of bright stars. The earliest records of globular clusters date back centuries. One of the first to notice these groupings was the British astronomer Charles Messier in the 18th century. This man, who dedicated his life to cataloguing celestial objects, did not know he was making history. When he observed the Hercules globular cluster, he catalogued it as a diffuse object. It was an important step, but who could imagine that those diffuse spots were actually collections of thousands of stars? As the years went by, more astronomers began to explore these mysterious objects, each adding their own knowledge and contributing to the collective understanding. With the arrival of the telescope, the story of globular clusters took an exciting turn. The stars that once appeared to be just spots in the sky began to reveal themselves in all their splendor. By the late 19th century, the German astronomer Wilhelm von Struve conducted more detailed observations and started to unravel the true nature of these clusters, revealing that they were much more complex than previously thought. Can you imagine the excitement he must have felt seeing those stars shine in such a compact space? Later, in the 20th century, technological advances continued to transform our understanding. With more powerful telescopes and more sophisticated photographic techniques, astronomers were able to study not only the shape and brightness of globular clusters, but also their composition. They realized that many of them contained very old stars, which opened a window to the past of the universe. What secrets did those ancient stars hold? Each cluster became a time capsule, a testament to the birth of our galaxy. Advances in astrophysics also played a crucial role in the history of globular clusters. With the development of theoretical models and computer simulations, scientists began to understand how these clusters formed and evolved. They realized that these groups of stars were not just random collections, but were bound by gravity and shared a common history. This revelation was like discovering that a group of friends had come together due to a shared event in the past. However, the story of globular clusters is not without its mysteries. Despite centuries of study, there are questions that still intrigue us. For example, why are some clusters more massive than others? What factors determine their formation and evolution? These questions have led astronomers to continue investigating, using increasingly advanced telescopes and collaborating on international projects to unravel the enigma of globular clusters. Over time, the observation of these clusters has also changed our perspective on the universe as a whole. What began as simple points in the sky has become a window into the cosmic past. Each globular cluster is like a stellar library, filled with information about the history of the galaxy. Isn't it amazing to think that by observing these groupings, we are looking back in time to the moments when the first stars formed? The relationship between globular clusters and the evolution of galaxies has been another exciting topic of study. As astronomers have unraveled the history of these clusters, they have discovered that they are not just ancient artifacts, but also play an active role in galactic dynamics. The way they interact with other stars and structures within the galaxy is key to understanding how galaxies have formed and evolved over time. In the 21st century, the study of globular clusters has reached new heights. Space missions and cutting-edge telescopes have allowed for unprecedented images and data. These advances have revealed surprising details about the chemical composition of the stars in the clusters, as well as their distribution and dynamics. Each new discovery brings us a little closer to solving the many enigmas surrounding these fascinating groups of stars. The history of globular clusters is, in many ways, a story of human discovery. From the first observers to modern scientists, each generation has contributed its own knowledge and expanded our understanding of the cosmos. It is a reminder that, although astronomy may seem like a technical and complicated field, at its essence, it is a journey of curiosity and exploration. As we look to the sky and contemplate these ancient clusters, we are not just observing stars. We are connecting with the history of the universe and the endless quest for answers about our place in it. Thus, the story of globular clusters does not end here. It will continue to evolve as we keep exploring, questioning and discovering, reminding us that within each star there are stories to tell and mysteries to solve. Globular clusters are like vast archives of ancient stars, a cosmic treasure that holds secrets about the early days of our galaxies. But how do these mysterious groupings of stars form? The answer to this question takes us on a fascinating journey through time and space, where interstellar matter plays a crucial role. To begin with, let's think of the universe as a large construction workshop, where different materials come together and assemble to create something new. In this workshop, interstellar matter, which is primarily composed of gas and dust, is the raw material. This matter is distributed across different regions of space, waiting to be used in the formation of new celestial bodies. When the conditions are right, these clouds of matter begin to collapse under their own gravity. It's like having a pile of sand in a bucket, and when you squeeze it, the sand starts to compact, forming a more solid structure. As this matter gathers, collisions and interactions between particles occur. This process generates heat, and eventually the temperature and pressure within the cloud become so high that stars begin to form. But what happens to all those stars that are born in the same place? In the case of globular clusters, these stars not only are born but also remain bound together by gravity, forming a kind of stellar family. Now imagine that each star in a globular cluster is like a member of a large community. Over time, these stars interact with each other, sharing resources and affecting each other's movements. This dense and dynamic environment gives rise to a variety of interesting phenomena. For example, some stars may merge, creating larger and brighter stars. Others may be expelled toward the outskirts of the cluster, as if they are venturing out into the vast universe. One of the most intriguing aspects of globular cluster formation is their age. Most of these clusters formed billions of years ago, shortly after the Big Bang. This means they contain the oldest stars we can observe, providing us with a unique window into the history of the universe. By studying these stars, astronomers can learn about the composition of the early universe and the conditions that led to the formation of galaxies. But what about the diversity among globular clusters? Not all are the same. Some are dense and compact, while others are more dispersed. This variability is due to factors such as the amount of matter present in the original cloud and the environmental conditions at the time of their formation. Each cluster has its own history, and understanding these differences helps us form a more complete picture of how the universe developed. A key element in the formation of globular clusters is the process of metallicity. In astronomy, metals refers to any element that is not hydrogen or helium. The first stars in the universe were almost entirely made of hydrogen and helium, but as these stars lived and died, they created new elements. These elements spread through space when they died, enriching the interstellar medium. The amount of metals in a gas cloud can influence its ability to form new stars, which in turn affects the type of globular clusters that will form. Time also plays a fundamental role in the formation of globular clusters. As millennia pass, interactions between the stars within the cluster can lead to significant changes in its structure. Some stars may merge and create supernovae, while others may be expelled from the cluster. This continuous process of stellar birth and death contributes to the evolution of the cluster over time. Globular clusters are also like natural laboratories where astrophysical phenomena can be studied. For example, by observing how stars group and move within these clusters, scientists can learn about gravitational dynamics and how gravity acts on such enormous scales. This knowledge has applications beyond astronomy, as it can also help understand other complex systems such as Earth's climate and the formation of planetary systems. Furthermore, globular clusters can act as a mirror reflecting the history of the universe. By analyzing the light emitted by their stars, astronomers can determine their chemical composition and, from there, make inferences about the conditions of the interstellar medium in which they formed. This information is vital for understanding not only the evolution of the clusters but also the formation of galaxies and the development of the entire cosmos. In summary, the formation of globular clusters is an astonishing process that involves the interaction of matter, gravity, and time. These groupings of stars are witnesses to the history of the universe, and their study offers us valuable clues about how our galaxy formed and how it has evolved over the millennia. By understanding how they are born and develop, we can begin to answer fundamental questions about the origin and destiny of our own place in the vast cosmos. Globular clusters are like small islands of stars in the vast ocean of space. But where can we find them in the universe? The answer is fascinating. These clusters are generally located in the outer regions of galaxies. As if they are the guardians of the oldest secrets of the cosmos, their distribution is not random. They are tied to the history and evolution of the galaxies that host them. When observing a galaxy, it is common for globular clusters to group in spherical halos around the main galaxy, as if they were bright jewels in a necklace. This halo extends far beyond the galactic disk, which is the densest and most active part of the galaxy. But what does this mean for us? It offers clues about how galaxies formed and how they behave over time. Globular clusters act as stellar fossils, helping us understand the environment in which they developed. The location of globular clusters is also related to gravity. Being denser and more compact, these clusters have a strong gravitational field that allows them to keep their stars bound together despite the vastness of the surrounding space. Imagine that each star in a cluster is like a droplet in a water balloon. Gravity acts like the material of the balloon, keeping all the droplets together without letting them escape. If we look closer, we discover that there are differences in the number of globular clusters found in different galaxies. For example, elliptical galaxies, which are older, tend to have numerous globular clusters, while spiral galaxies, like our Milky Way, have fewer. This raises an intriguing question. Why are some galaxies richer in globular clusters than others? The answer may lie in their history and how they have interacted with other stellar systems over billions of years. Moreover, globular clusters are not alone in space. We often see them accompanied by other types of galactic structures, such as star disks and gas clouds. These clusters can influence the movement of nearby stars, acting almost like small centers of gravity that alter the course of objects passing nearby. This interaction helps us understand how galaxies form and evolve as a whole. When observing the sky, you are likely to encounter globular clusters at different stages of their life cycle. Some may be in the process of colliding with other structures, causing a mix of stars and gas. This phenomenon is a reminder that the universe is in constant change and that globular clusters are part of that dynamism. A fascinating aspect of the distribution of globular clusters is their relationship with dark matter. Although we cannot see dark matter directly, its gravitational influence is undeniable. Globular clusters appear to be distributed in a way that suggests the presence of this mysterious matter, acting as a map that points us to where it might be. This connection gives us a clue about the composition of the universe and how matter behaves on a large scale. We cannot forget that globular clusters are also fundamental to our understanding of cosmic time. By studying their location and distribution, astronomers can deduce the history of the galaxy that contains them. This leads us to wonder, what secrets might they reveal about the past of the universe? Each globular cluster can be like an ancient book filled with stories about the formation of stars and galaxies. However, not everything is static. Over time, globular clusters can also be influenced by external forces, such as the gravity of other galaxies or collisions with other clusters. This dynamics can lead to the creation of new stars and the destruction of others. How does this affect their distribution? It forces us to rethink what we know about galactic evolution. When we observe globular clusters, we can also wonder about their role in the future of the universe. As galaxies continue to evolve, it is likely that some of these clusters will merge, creating even more complex structures. This possibility invites us to imagine a future in which globular clusters are even more diverse and varied. Finally, when reflecting on the distribution of globular clusters, it is important to remember that each one is a window into the past of the universe. They are witnesses to cosmic history, and their study allows us to connect the dots between the present and the past. Thus, when observing the starry sky, We can see not only bright lights but also the echoes of an ancient time that still resonates in the vastness of space. What is the age of globular clusters and why is it so fascinating? To understand this, we must first think of time as a great line, where globular clusters are some of the oldest markers we can find. These celestial objects are like time capsules, offering us clues about the primitive universe, but what do they really tell us? Globular clusters are mostly old, some are up to 13 billion years old. Imagine that the universe is approximately 14 billion years old. In this context, globular clusters are like the grandparents of stars, silent witnesses to the history of the galaxy. Their existence gives us an idea of what the universe was like shortly after the Big Bang. Isn't it amazing to think that these groupings of stars have been there since almost the beginning of everything? By observing these clusters, astronomers can better understand the evolution of stars. Each star in a globular cluster has followed a similar path, but their individual stories can be different. Some have lived long and stable lives, while others have had dramatic fates, such as exploding in supernova. How does this influence our understanding of stellar evolution? The answer lies in the uniformity of their chemical composition. Most stars in globular clusters are rich in helium but poor in heavier elements, meaning they were born at a time when the universe had not yet produced many heavy elements. This gives us clues about the conditions in which they formed. Can you imagine a universe where hydrogen and helium were the protagonists? Without the diversity of elements we see today, these clusters, then, are like cosmic fossils that speak to us of a primordial past. The age of globular clusters also raises intriguing questions about the formation of galaxies. Being some of the first objects formed, they help us understand how galaxies assembled in the early universe. Like pieces of a puzzle, each globular cluster is placed in its spot, providing us with a clearer picture of galactic history. What secrets might they reveal about how the large structures we see today formed? Additionally, their age allows us to study the expansion of the universe by observing how these clusters are distributed and move. Astronomers can infer information about the rate of expansion of the universe. It's as if each cluster is sending signals about its journey through the cosmos, helping us unravel the mystery of how the universe behaves on a large scale. Isn't it exciting to think that these groupings of stars can give us answers about the fate of the cosmos? Research on globular clusters also has implications for dark matter. This mysterious substance is believed to make up most of the universe, yet it remains difficult to detect. Globular clusters, being so old and stable, can act as natural laboratories where scientists search for clues about dark matter. What revelations might arise from these studies in the future? Another intriguing question is, why are some globular clusters older than others? The answer may be related to the environment in which they formed. Clusters that formed in dense regions of the universe tend to be older, while those in less populated areas may be younger. It's as if the universe had different neighborhoods, each with its own pace of life. What lessons can we learn from this diversity? Globular clusters also provide us with a valuable resource for studying the history of the universe. By analyzing the age of the stars within a cluster, astronomers can determine when the cluster itself formed. This, in turn, provides a timeline for the evolution of galaxies. What fascinating narrative is hidden in these ancient groups of stars? As we explore more about the age of globular clusters, we encounter a deep connection between time and space. These celestial objects show us that although time moves on and the universe changes, there are aspects that endure and tell us invaluable stories. What other stories are waiting for us as we delve deeper into the study of these clusters? As we continue our research, globular clusters become a crucial tool for understanding not only the history of the universe but also its future. Through them, we can gain insights into the formation of new stars and the evolution of galaxies. What other mysteries will be revealed along the way? Finally, it is essential to recognize the importance of these ancient clusters in our quest for knowledge. Their age and composition tell us much about the past of the universe, and their study will remain fundamental to clearing up the doubts that still persist. How many more secrets are hidden in the stars that make up these clusters? In conclusion, the age of globular clusters is not only fascinating but also essential for our understanding of the cosmos. Each cluster is like an ancient book waiting to be read, full of stories about the past and lessons about the future. Are you ready to keep exploring and discover what these ancient witnesses of the universe have to offer? Globular clusters are like large groupings of stars that seem to have come together to form a community. However, what kind of stars inhabit these groups, and why are they so special? To understand this, it is essential to explore the unique characteristics of these stars and how they differ from those we find in other parts of the universe. First, let's focus on the age of the stars in globular clusters. Most of them are old, some over 10 billion years. Imagine a wise elder who has lived through many experiences. These stars have been in the universe since its beginnings. This makes them true cosmic fossils, capable of telling us stories about the formation of our galaxy and the universe itself. What secrets could these centenarian stars reveal to us? Despite their advanced age, most stars in globular clusters are G-type stars, like our Sun, but we also find a fascinating variety of stars at different stages of evolution. Some are red giants, having expanded their surfaces and changed drastically over their lifetimes. Others are white dwarfs, representing the final stage of a star's life similar to the Sun. How do these stars feel as they age in such a dense and competitive environment? The density in a globular cluster is remarkable. Imagine a place where thousands of people are packed into a small space. That is what happens with the stars in these clusters. This closeness leads to very interesting gravitational interactions. Stars can come so close that, at times, one star can steal material from another, creating a fascinating cosmic dance. What kind of relationships form in such an intense environment? Moreover, the variety of colors we see in these clusters is astounding. The younger stars shine in blue hues, while the older ones emit yellow or red light. This color palette is like a stellar rainbow that offers us clues about the history of each star. But why is it important to know these color differences? Stars in globular clusters are also a natural laboratory for studying stellar evolution. Since they all formed roughly at the same time and in the same place, astronomers can compare their characteristics and better understand how stars evolve under different conditions. What lessons can we learn from this group of stars that have shared the same fate? Gravitational interaction not only affects individual stars but can also lead to spectacular phenomena. Sometimes globular clusters host stars that merge, creating supernovae. This type of explosion is like a fireworks display in the cosmos, releasing enormous amounts of energy and throwing heavy elements into space. What effect do these explosions have on the galactic environment? On the other hand, within these clusters, we can also find neutron stars and black holes, which are remnants of previous supernovae. These denser stars are like the remnants of a party where only the strongest remain. How do these types of stars affect the balance of the cluster and the stars surrounding it? The study of stars in globular clusters also provides us with clues about the chemical composition of the universe. As stars die and explode, they release elements into space that are fundamental for the formation of new stars and planets. Thus, these stars act as a kind of cosmic factory. What kinds of elements have they created to shape our universe? The dynamics of stars in a globular cluster is a fascinating topic. Gravitational interactions can lead some stars to be expelled from the cluster, while others may be drawn toward the center. This movement is constant and varied, creating a cosmic ballet. How does this dynamics influence the life of the stars and the evolution of the cluster as a whole? The brightest stars in a globular cluster are often the target of astronomers seeking to understand the structure and history of the universe. By studying these stars, secrets about the formation of the galaxy and the distribution of matter can be unraveled. What stories could these stars tell if they could speak? The relationship between the stars in a globular cluster and their environment is another fascinating aspect. As they move and evolve, they can influence the formation of new stars nearby. This process is like a teacher who, with their experience, guides young students. How do these processes feed back into an endless cycle of creation and destruction as we delve deeper into the study of stars in globular clusters? It is essential to consider the impact of modern technology. Advanced telescopes and observatories allow us to observe these clusters with unprecedented detail. This has led to surprising discoveries about the nature of stars and their behavior. What new secrets will technology reveal to us in the future? Finally, we cannot forget the importance of the diversity of stars in globular clusters. Each star has its own story, and studying them together offers us a broader view of how the universe works. Just as each person has a story to tell, each star in a cluster contributes its own experience to the cosmic narrative. What other wonders await us in the vast ocean of the cosmos? Through this exploration of the stars in globular clusters, we not only learn about their nature but also begin to understand our place in the universe. How does all this connect with the quest for answers about the origin of our existence? Each star is a point in the vastness of space, but together they create a brilliant narrative that invites us to continue investigating and discovering. What is the true cosmic ballet unfolding among globular clusters? In this vast universe where stars seem to dance in an eternal choreography, globular clusters move like a group of dancers, each with its own rhythm, yet all in perfect harmony. These groups of stars are not just static collections, but dynamic systems that tell us stories about their interactions, movements, and evolution over time. It is often thought that globular clusters are simply groupings of ancient stars. But the reality is much more fascinating. Within them, stars intertwine in a delicate gravitational balance. This balance is essential as each star pulls on the others, creating a play of forces that maintains the cohesion of the cluster. However, as time progresses, this balance can be disturbed. What happens then? Stars begin to move more freely, and some may even be expelled from the cluster. Imagine a party where, after a while, some guests decide to step out and explore the outside world. This is how stars behave in a globular cluster. The speed at which these stars move is astonishing. Some can reach speeds of hundreds of kilometers per second. To put this in perspective, imagine you are in a car on a highway. If you drive at 100 kilometers per hour, you will already feel fast. Now imagine going more than double that speed, surrounded by others driving at the same velocity. The sensation of movement is intense and sometimes chaotic. Such is life within a globular cluster, where stars not only move rapidly but also interact with each other in complex ways. The interaction among stars in a globular cluster can lead to the formation of binary systems. What does this mean? Imagine two friends who decide to always be together, sharing everything they have. In space, this translates to stars orbiting around a common center. Over time, these systems can become unstable, which can result in spectacular explosions such as supernovae when one of the stars exhausts its fuel. This dynamic not only affects the stars but also impacts the chemistry of the cluster as a whole. But there is more to this cosmic drama. As the more massive stars exhaust their life, they may leave behind remnants such as neutron stars or black holes. How does this affect their companions in the cluster? It's a bit like when a conductor leaves the stage. The remaining musicians must quickly adapt to the new dynamics. The stars left in the cluster must readjust their trajectories, and this can lead to significant changes in the structure of the cluster. Globular clusters are not just a visual spectacle, they are also natural laboratories where the laws of physics can be studied in action. By observing how they move and evolve, astronomers can test theories about gravity, stellar dynamics, and dark matter. Isn't it astonishing to think that by looking at these clusters, we are seeing a reflection of the fundamental forces that govern the universe? Furthermore, the way globular clusters are distributed in galaxies is also revealing. These clusters tend to be located in the galactic halo, a region surrounding galaxies. This suggests that they have been there since the early days of galaxy formation. Imagine that globular clusters are the fossils of the universe's history, telling us how things were in ancient times. The evolution of a globular cluster is not a linear process. Over billions of years, clusters can experience mergers and interactions with other clusters or even be part of the formation of new galaxies. These events can be compared to changes in a river current, where different streams combine and flow together, creating a new ecosystem. The dynamics of globular clusters are similar, where movement and interaction can give rise to new structures and behaviors. The study of the dynamics of globular clusters also helps us understand how galaxies form and distribute. By observing these groupings of stars in motion, astronomers can make inferences about the evolutionary history of the galaxies in which they reside. Each globular cluster is like an open book, providing clues about the formation and evolution of its parent galaxy. In this context, the question arises, what role will globular clusters play in the future of the universe? As the universe continues to expand and evolve, globular clusters will keep moving and changing. Some will merge, while others will disperse. This cosmic dance is far from over. In fact, we may be only at the beginning of a long story. Finally, remember that globular clusters are more than just a collection of stars. They are witnesses of time, guardians of cosmic secrets, and protagonists of a dynamic spectacle that continues to unfold. Every movement, every interaction offers us a window into the past and future of the universe. So, the next time you look up at the sky and see a globular cluster, remember that you are observing a dance that has been ongoing for billions of years. A cosmic ballet that connects us all to the vast and mysterious cosmos we inhabit. What lies between globular clusters and black holes? That is a question that has intrigued astronomers for decades. Imagine a gigantic whirlpool in space where stars group together in a gravitational embrace so strong that none can escape. That is a globular cluster, a collection of thousands, sometimes millions of stars that have coexisted for billions of years. However, at the heart of some of these clusters, even deeper mysteries are hidden. The relationship between globular clusters and black holes is fascinating. On one hand, we have black holes, those cosmic monsters that can swallow even light. On the other, globular clusters, which seem to be the perfect setting for these mysterious entities to hide. But how do these connections form? Some scientists suggest that in the early days of the universe, globular clusters were the places where optimal conditions for black hole formation existed. Over time, some stars in these clusters exhaust their fuel, collapse, and transform into black holes. Thus, the cluster becomes an environment where black holes can proliferate. Imagine a garden where seeds turn into plants and suddenly, some of them transform into enormous trees. But that's not all. There are globular clusters that appear to have a supermassive black hole at their center. What does this mean? It means that as stars orbit around this black hole, they could be drawn toward it, creating an impressive cosmic spectacle. And so, the dance between stars and black holes becomes a gravitational ballet that lasts billions of years. Sometimes astronomers wonder, can a globular cluster be home to more than one black hole? The answer seems to be yes. Simulations have shown that in certain clusters, two black holes can interact, merge, and create an even more massive one. This is like two couples joining together to form an even more impressive duo in a dance. Now, what role do black holes play in the life of a globular cluster? A black hole can act like a magnet, attracting nearby stars around it. This can alter the dynamics of the cluster, leading to a redistribution of stars. Imagine a group of friends at a party. If one of them starts dancing enthusiastically, that can draw others closer to them, completely changing the energy of the atmosphere. In some cases, globular clusters with black holes seem to be brighter than those without them. This is because when stars fall into the black hole, they release enormous amounts of energy in the form of radiation. Thus, the cluster lights up as if it were celebrating a party in space. Research on these phenomena has grown in recent years. With advanced telescopes and observation techniques, astronomers have been able to identify globular clusters that harbor black holes. This is a significant step in our understanding of the universe, but many questions remain unanswered. For example, how do black holes in globular clusters affect the evolution of the galaxies in which they reside? It has been proposed that these black holes may influence the formation of new stars or even the dynamics of the galaxy itself, as if a conductor were guiding the rhythm of an entire cosmic symphony. And not only that, but by studying the relationship between globular clusters and black holes, we can also gain clues about dark matter. Dark matter is that part of the universe that we cannot see, but which seems to play a fundamental role in the structure of the cosmos. By analyzing how globular clusters and black holes behave, scientists can infer the influence of dark matter in these interactions. The truth is that the connection between globular clusters and black holes is a mystery that we have only just begun to unravel. As technology advances, our observational tools become more powerful and we get a little closer to the truth. Each discovery is like a piece of the puzzle that helps us better understand the vast universe we inhabit. So the next time you look up at the starry sky, think of those globular clusters that may be hiding black holes within. It is a reminder that despite what we see, the universe is full of secrets and wonders that we still have yet to discover. The bright stars we see are just the surface of a sea of cosmic complexities that invite us to keep exploring. What is the great mystery surrounding globular clusters and their relationship with dark matter? To understand this, we must first think of the universe as a vast ocean filled with stars, planets, and other celestial objects. In the midst of this ocean are globular clusters, which are like dense islands of ancient stars. Now, dark matter is like an invisible background of that ocean, a substance that we cannot see directly, but that influences everything happening around us. But how are these two intriguing phenomena related? Globular clusters are composed of thousands or even millions of stars, all bound together by the force of gravity. Throughout their existence, they have maintained their shape and structure, allowing them to withstand the influence of the dark matter surrounding them. But what exact role does this dark matter play in their formation and evolution? The answer to this question could reveal a lot about the history of the universe. Dark matter is a type of matter that does not emit light or energy, making it practically undetectable with conventional telescopes. However, scientists have deduced its existence from its gravitational effects on visible matter. Imagine you are in a park and see a group of people playing ball. Although you cannot see the person throwing the ball, you can deduce their position and strength from the trajectory of the ball. In the same way, astronomers can infer the presence of dark matter from the behavior of stars in globular clusters. One of the most fascinating questions is, how does dark matter affect the formation of these clusters? It is believed that dark matter plays a crucial role in the creation of the universe's first structures. In its early stages, the universe was a chaotic place, full of small density fluctuations. Dark matter, being more abundant than visible matter, acted as a cosmic skeleton, attracting normal matter and helping to form the first galaxies and globular clusters. As globular clusters formed and evolved, dark matter continued to influence their dynamics. But how does it do this? Dark matter creates a gravitational well that affects the movement of stars within the clusters. Just as a group of dancers moves in sync due to the music, the stars in a globular cluster move under the influence of the gravity imparted by the surrounding dark matter. Without this force, the clusters could disintegrate and lose their distinctive characteristics. There are different theories about how dark matter is distributed in relation to globular clusters. Some research suggests that clusters may be located in areas of high dark matter density, while other theories propose that dark matter could be distributed more uniformly. This uncertainty makes the study of globular clusters and their relationship with dark matter an exciting and evolving field of research. A fascinating approach is that of globular clusters in nearby galaxies. Scientists are using advanced telescopes to study these clusters in detail. By observing how they move and are distributed, they can gain clues about the amount and location of dark matter in those galaxies. This is like trying to uncover the secrets of a family recipe by observing how the ingredients combine as they cook. The relationship between globular clusters and dark matter also helps us understand the formation of large-scale structures in the universe. For example, the way clusters group and distribute can provide information about how large galactic structures formed. It's like mapping the evolution of a family tree, where each branch represents a unique story of growth and development. Additionally, there is an intriguing aspect of the relationship between globular clusters and dark matter that relates to black holes. Some studies suggest that globular clusters may contain supermassive black holes at their center, adding another layer of complexity to this relationship. These black holes, like dark matter, are invisible, but their influence can be observed through the effects they have on nearby stars. As astronomers continue to explore these connections, more questions arise. How do the interactions between dark matter and globular clusters affect the formation of new stars? Can globular clusters be witnesses to the mystery of dark matter's disappearance? Each answer opens the door to new questions, making this field of study one of the most intriguing in modern astronomy. In summary, the relationship between globular clusters and dark matter is a fascinating territory full of surprises. As we advance in our understanding of these two phenomena, we discover not only more about the clusters, but also about the very nature of the universe. Dark matter, although invisible, becomes a key player in the story of stars and, in turn, in our own story as observers of the cosmos. As we continue to investigate, each new discovery brings us a little closer to unraveling the secrets of the universe and our place in it. So who knows what surprises the future holds in this quest to understand dark matter and how it intertwines with globular clusters. In the vast universe, observing globular clusters is akin to contemplating the jewels of a crown. But how can we approach these fascinating structures? The answer lies in the technology we have developed to explore the cosmos. Telescopes, those giants that gaze at the sky, are just one of the tools we use to study these magnificent groups of stars. Optical telescopes are like enormous eyes that capture the light from the stars. These instruments have existed for centuries, but today their evolution has been astonishing. Imagine using a telescope on top of a mountain far from the city lights. The clarity of the sky allows us to see not only the globular clusters, but also the details that tell us stories of their formation and evolution. Every flash of light we see is an echo of a distant past, a window into the history of the universe. What about the light we cannot see? This is where radio telescopes and infrared telescopes come into play. While our eyes can only perceive a small fraction of the electromagnetic spectrum, these telescopes allow us to explore wavelengths that are invisible to us. By observing a globular cluster through a radio telescope, we can detect the activity of gas and dust surrounding the stars, revealing secrets that would otherwise remain hidden. Satellites also play a crucial role in observing globular clusters. These space observatories, like the Hubble Space Telescope, offer us a unique perspective free from the Earth's atmosphere. Imagine having an unobstructed view where the light from the stars shines in all its splendor. Thanks to these missions, we have been able to capture stunning images of globular clusters, showcasing details we had never been able to appreciate before. But what about the information we collect from these observations? Each image, each spectrum of light, is like a puzzle we must solve. Astronomers use analysis techniques to unravel the chemical composition of the stars within globular clusters. By studying the light they emit, we can discover what they are made of, their age and their evolution. This helps us understand the role they play in the universe and how they relate to other galactic components. As we advance in this technological era, artificial intelligence has become an invaluable tool for analyzing astronomical data. With the ability to process large amounts of information quickly and efficiently, algorithms can identify patterns that might be overlooked at first glance. This means we are getting closer to answering questions that once seemed impossible to resolve. International collaboration is another fundamental aspect of observing globular clusters. Astronomers from around the world share their findings and work together on joint projects. This synergy allows us to gather an incredible amount of data, enriching our collective understanding of the universe. Each discovery becomes a building block in the construction of our knowledge, and each studied cluster adds a new layer to the cosmic story. The next time you look up at the starry sky, think of all the work behind the observation of those globular clusters. The combination of telescopes, satellites, artificial intelligence, and international collaboration provides us with unprecedented access to the vastness of the universe. Each of these elements is like a piece of a puzzle that, when put together, reveals the beauty and complexity of the cosmos. So what future awaits us in the observation of globular clusters? With each technological advance, the possibilities are endless. New telescopes and missions are on the way, promising to delve even deeper into the mysteries of the universe. The exploration of space is a continuous journey, and each discovery brings us closer to understanding our place in the cosmos. As we reflect on the importance of globular clusters and the technology we use to observe them, it is essential to remember that each star in those clusters has a story to tell, from its birth to its death. Each star is a witness to the evolution of the universe. Through observation, we not only gain a better understanding of these celestial bodies, but also connect with our own history as humanity. So the next time you hear about a discovery in a globular cluster, remember that behind that news is a monumental effort by scientists, engineers, and dreamers, all working together to unveil the secrets of the universe. Human curiosity and the pursuit of knowledge are powerful forces that drive us to keep exploring, to keep asking questions, and above all, to keep marveling at the vastness of the cosmos. Globular clusters are not only found in our Milky Way. In fact, there are many of them in other galaxies, and each tells a unique story about the formation and evolution of the universe. But how different can these clusters be compared to those we see in our own galaxy? By observing other globular clusters, astronomers can better understand the diversity of these objects and how each galaxy has its own collection of ancient stars. One fascinating aspect is that globular clusters in other galaxies can vary significantly in size and density. Some are so compact that they appear as a ball of tightly packed stars, while others are more dispersed, as if they are in a cosmic dance. This variety helps us formulate intriguing questions. What factors determine these differences? Is it the history of the galaxy that influences the formation of its globular clusters? Distance also plays an important role. Some globular clusters are located millions of light years away from us, in galaxies like Andromeda or the Local Group. Imagining these distances is like trying to visualize how many car trips would be needed to reach those places. It is overwhelming. This remoteness poses a challenge for scientists trying to study these clusters. However, thanks to advances in technology such as space telescopes, we can capture the light from these distant objects and learn about them. In the context of galaxy formation, it is interesting to consider how globular clusters can act as stellar fossils. They represent the early stages of star formation in the universe, meaning they provide clues about what the initial conditions of the cosmos were like. But how does this relate to clusters in other galaxies? By studying these fossils in different galactic environments, astronomers can reconstruct the history of the universe. The comparison between globular clusters from different galaxies can also reveal information about dark matter. Certain clusters in more massive galaxies have been observed to have a greater concentration of dark matter, suggesting a connection between the structure of the cluster and the distribution of this mysterious substance. Could it be that globular clusters help us understand not only the matter we see but also the matter we cannot see? On the other hand, the interaction between globular clusters and other galactic structures offers us a more comprehensive view of their role in the universe. For example, some clusters are found in the halo of galaxies, while others are closer to the core. This location can influence their evolution and the final fate of the stars that comprise them. The question that arises is, how does the gravity of the host galaxy affect the life of these globular clusters? Many globular clusters also harbor stars that are much older than those found in the disks of galaxies. This means that by observing these clusters in other galaxies, we are not just looking at a group of stars, but we are looking through time. Each star in a globular cluster has its own story, allowing us to explore how the universe has changed over billions of years. Globular clusters in other galaxies can also be home to extraordinary phenomena. For example, some exhibit variable stars or even binary stars, which are systems of two stars orbiting each other. These systems can provide clues about stellar evolution in different environments. Each discovery brings new questions. How do these stars behave in an environment different from ours? What do they tell us about the chemistry and physics of the host galaxy? As astronomers continue their search for globular clusters in other galaxies, they are also using computer simulations to model how they should appear. These simulations help predict the distribution and dynamics of globular clusters under different conditions. By comparing these simulations with real observations, scientists can validate their theories and adjust their models. Science advances through this dialogue between observation and simulation. Technology plays a crucial role in this process, and state-of-the-art telescopes, such as the James Webb Space Telescope, are opening new doors for the exploration of globular clusters in other galaxies. With its ability to observe in infrared wavelengths, we can see through the dust and gas that often obscure these fascinating objects. What secrets will this new technology reveal about globular clusters? Furthermore, the study of these clusters is not limited to their composition and structure. There is also a growing interest in how these clusters may influence the formation of new stars in their surroundings. In some galaxies, globular clusters have been observed to act as catalysts for star formation, providing the necessary material for new stars to be born. Could it be that these ancient groups of stars are responsible for bringing new life to their galaxies? Each discovery about globular clusters in other galaxies brings us a little closer to understanding the great puzzle of the universe. The story of these clusters is one of interaction, evolution, and discovery. As we explore beyond our own galaxy, we begin to understand that each globular cluster tells a story that intertwines with the broader narrative of cosmic formation. In summary, the exploration of globular clusters in other galaxies not only offers us a glimpse into the diversity of the universe, but also helps us understand how galaxies form and evolve. Each cluster is a reminder that although we are separated by vast distances, we are all connected through the history of the universe. What more will these mysterious groups of stars reveal to us in the future? The answer awaits discovery by the astronomers of tomorrow. Did you know that globular clusters are like cosmic fossils that tell us the story of the universe? These groups of stars, which formed in the early stages of the cosmos, are crucial for understanding not only how galaxies have developed, but also how the universe has behaved as a whole. But what do they have to do with cosmology? Join me on this journey through the stars, where we will explore the fascinating relationship between globular clusters and our understanding of the universe. Let's start with an intriguing question. Why do astronomers consider globular clusters as cosmic laboratories? The answer lies in their age and composition, being some of the oldest objects in the universe. Formed over 11 billion years ago, these clusters offer a unique window into the past. By studying them, scientists can reconstruct what the universe was like in its early days, before galaxies as we know them today began to form. Imagine that each star in a globular cluster is like a witness in a trial. Each one has a story to tell about the conditions in which it formed and how it has evolved over time. But here arises another question. How can those individual stories help us understand the grand narrative of the cosmos? The key lies in chemistry. The stars in these clusters have similar chemical compositions, suggesting that they formed in the same place and time. This allows astronomers to study the conditions of the early universe as if they were reading an ancient book. The relationship between globular clusters and cosmology becomes even more interesting when we consider their distribution in space. These clusters are not randomly scattered. Their location around galaxies, especially in the outer regions, suggests how galaxies have grown and evolved. By analyzing how globular clusters are grouped, scientists can infer the history of galaxy formation and how it has interacted with its environment. Thus, globular clusters become indicators of the architecture of the universe. Why is the study of dark matter so important in relation to globular clusters? Imagine that the clusters act as a treasure map where dark matter is the hidden treasure. Globular clusters are denser in dark matter than other regions of space, which means that studying them can provide clues about the nature of this mysterious substance that makes up a large part of the universe. Understanding how dark matter affects globular clusters could revolutionize our understanding of physics and cosmology. Let's talk about the expansion of the universe. Have you ever wondered how globular clusters relate to this phenomenon? When the oldest stars in the clusters are analyzed, the rate of expansion of the universe can be measured. Thus, these clusters become tools to measure not only the speed at which the universe is expanding, but also to better understand its history and future. One fascinating aspect is how the study of globular clusters has changed over time. In the past, astronomers could only observe them with the naked eye or with basic telescopes. Nowadays, thanks to technological advances, we can use space telescopes and high-resolution observatories to study the light they emit. This has allowed us to discover more about their composition and structure, revealing details that were previously invisible. This advancement has enriched our understanding of how clusters formed and evolved. Another intriguing question is, what do globular clusters tell us about the formation of new stars? Although many of them are old and mostly composed of ancient stars, their study can provide valuable information about the life cycle of stars. By understanding how the stars in these clusters interact with each other, astronomers can learn about the stellar formation processes occurring in other regions of the universe. The relationship between globular clusters and black holes is also a fascinating topic. Some clusters harbor massive black holes at their center, raising questions about how these entities form and evolve in such a dense environment. This interaction between globular clusters and black holes can offer clues about the evolution of galaxies and the role black holes play in the dynamics of the universe. As we advance in the study of globular clusters, new questions arise. How will our theories about the universe change as we discover more about these ancient groups of stars? Each new discovery has the potential to challenge what we think we know and open new doors to scientific curiosity. Globular clusters are not just objects of study, they are also catalysts for new ideas and theories. The future of research on globular clusters is bright, with more advanced telescopes and new space missions in development. Our ability to observe and analyze these fascinating objects will continue to grow. This could lead us to discoveries that transform our understanding of cosmology and the origin of the universe. In summary, globular clusters are more than just groupings of stars. They are witnesses of the past, keys to understanding the present, and guides for the future of the universe. By studying their history, composition, and dynamics, scientists can unravel the mysteries of the cosmos and perhaps answer some of the deepest questions about our place in the universe. So the next time you look up at the starry sky, remember that each twinkle may be an echo of the universe's history, waiting to be discovered. The relationship between globular clusters and star formation is fascinating and complex. These massive groupings of stars are not just a visual spectacle in the sky, they also act as true cosmic laboratories where we can observe the processes of star formation in action. How do stars form in these ancient stellar groups? To understand this, it is crucial to explore the unique environment that globular clusters offer. First of all, it is important to remember that globular clusters are primarily composed of very old stars, many of which formed during a time when the universe was significantly younger. This means that the conditions under which these stars began to form were very different from those we find in current nebulae. Being closer to the beginning of star formation in the universe, globular clusters provide us with a window into the past. When astronomers observe a globular cluster, what they are seeing is a set of stars that were born almost at the same time and from the same cloud of gas and dust. This cloud, before becoming stars, was composed of hydrogen, helium, and traces of other elements. It is as if you have a large block of mass that, under the influence of gravity, begins to fragment and collapse. As this happens, the denser areas of the cloud turn into stars. But why is this process so special in globular clusters? One reason is that, with the stars so concentrated in a globular cluster, gravity acts more effectively. Imagine a group of friends pushing each other in a confined space. Each push can cause some to slide toward the center. In the case of globular clusters, the same principle applies to the collapsing matter that forms stars. The gravity in these tight spaces can lead to an increase in the rate of star formation. However, not all stars that form in a globular cluster are the same. Some become massive stars that, at the end of their life cycle, can explode as supernovae, while others become smaller, longer-lasting stars. This diversity in star formation creates a dynamic environment where different stages of stellar evolution can be studied. The fusion of elements within these stars is also an interesting point. Throughout their lives, the stars in globular clusters produce heavier elements through nuclear fusion processes. When they explode as supernovae, they release these elements into space, enriching the interstellar medium. This enrichment is fundamental for the formation of future generations of stars and planets, creating a continuous cycle of stellar birth and death. That said, what happens to the stars that do not explode? In a globular cluster, many of them become white dwarfs, which are the remnants of stars that have exhausted their nuclear fuel. These white dwarfs, although they do not shine with the same intensity as their younger siblings, contribute to the total mass of the cluster and can gravitationally interact with other stars. The interaction between these stars is also fascinating. In such a dense environment, stars can come close enough to exchange matter or even merge. This can lead not only to the formation of new stars, but also to the creation of unique stellar systems such as binaries or neutron stars. So how do astronomers study these processes in globular clusters? Using powerful telescopes and advanced observational techniques, scientists can analyze the light emitted by these stars. Each star has a unique signature in its light spectrum, allowing them to identify its composition, age, and temperature. This analysis not only helps to understand the history of individual stars, but also that of the cluster itself. As we advance in our understanding of globular clusters, we also discover their importance in star formation. These groups act as natural laboratories where the processes of stellar creation can be observed in action, revealing secrets about the universe that would otherwise remain hidden. Each globular cluster is like an ancient book that narrates the story of star formation in the cosmos. Reflecting on the relationship between globular clusters and star formation, it is evident that these ancient groupings are not just collections of stars, but key pieces in the grand puzzle of the universe. Their study not only helps us understand how stars are born, but also sheds light on the evolution of galaxies and the history of the cosmos as a whole. In conclusion, globular clusters are like time capsules that allow us to explore the history of star formation. By studying these groups, astronomers are not only unraveling the mysteries of the past, but also laying the groundwork for understanding the future of the universe. How does a small group of stars influence the evolution of an entire galaxy? Globular clusters, those spheres filled with ancient stars, play a crucial role in the grand theatre of the universe. Let's think of them as the grandmothers of a galaxy, bearers of stories and secrets that have been passed down over billions of years. Their existence not only speaks to us about the past, but also helps us understand how galaxies grow and change over time. The relationship between globular clusters and galactic evolution is deep and fascinating. Globular clusters are like time capsules, preserving information about the early stages of our galaxy's formation. Being some of the oldest objects in the universe, their study provides clues about how galaxies, including our own, have evolved since their beginnings. What secrets do these ancient groups of stars hold? Each globular cluster is a microcosm, a small stellar community that has survived the harshness of cosmic time. By observing these groupings, astronomers can unravel the processes that shaped galaxies. For example, in their gravitational interactions, globular clusters can influence the distribution of gas and dust in their neighborhoods, which in turn affects the formation of new stars. Imagine a party where stars move in groups. Globular clusters are those groups of friends who, over the years, have learned to dance together. Their movement and gravitational attraction can alter the rhythm of the surrounding stars, facilitating the creation of new stellar generations. Have you ever wondered how such a compact group can have such a large impact? Globular clusters also act as natural laboratories. By studying the chemical composition of their stars, astronomers can gain insights into the environment in which they formed. This is fundamental, as the chemistry of the gas and dust in which stars are born determines their characteristics. Thus, globular clusters illuminate the path toward understanding galactic chemistry and how it has evolved. As galaxies grow and develop, globular clusters can be captured by the gravity of other galaxies. This process of merging globular clusters with other stellar formations can trigger dramatic events. What happens when two clusters meet? The answer is a cosmic dance that can lead to the creation of new stars or even the destruction of entire clusters. This interplay of gravitational forces can be compared to two rivers meeting and mixing their waters, creating new currents. The history of galactic evolution is intertwined with that of globular clusters. These groups of stars can act as witnesses to cosmic events, such as galaxy mergers or the formation of supermassive black holes. Their study allows us to map the history of the universe, revealing the crucial stages that led to the formation of the stellar systems we know today. The interactions between globular clusters and the rest of the galaxy are also fundamental to understanding the galactic halo, the diffuse region of dark matter and gas that surrounds galaxies. Globular clusters being situated in this halo help us understand the distribution of matter in the universe. What mysteries about dark matter could we unveil through them? Not everything is harmony in the cosmos. Sometimes globular clusters can be stripped of their stars when they get caught in the gravitational pull of other galaxies. This phenomenon, known as disruption, shows us how fragile these structures can be in the grand scheme of the universe. Just like a group of friends who, upon moving to a new city, scatter in different directions, globular clusters can lose part of their essence over time. From a broader perspective, the influence of globular clusters on galactic evolution also raises questions about the fate of galaxies. Will these ancient groups of stars continue to exist in the distant future? As the universe continues to expand, it is possible that globular clusters will become relics of a bygone era, reminders of a time when stars shone more brightly. Globular clusters are also a link between the past and the future. By studying their characteristics and behavior, scientists can make conjectures about the direction in which our own galaxy will develop. Could we be witnessing the first steps toward the formation of new galaxies and clusters in a distant future? Galactic evolution is not just a physical process, it is also a narrative filled with drama and beauty. Globular clusters, with their rich history and importance in the dynamics of galaxies, are protagonists in this cosmic narrative. As we explore them, we discover not only their past, but also their role in the future of the universe. Reflecting on all this, the presence of globular clusters reminds us that each star has its story and that, although they may be distant, their influence is palpable in the vast expanse of the cosmos. Thus, when we look up at the night sky, we can appreciate not only the beauty of the stars, but also the profound tale they tell us about the universe and its evolution. The story of globular clusters is a tale of resilience and transformation, inviting us to continue exploring and learning. As we delve deeper into their study, we keep unraveling the mysteries of the universe, one cluster at a time. Globular clusters have fascinated humanity for centuries, even long before we had the ability to observe them with telescopes. Since ancient times, cultures have looked to the sky for answers and meaning. Have you ever felt that a group of stars might hold a secret of the universe? In many mythologies, globular clusters have been interpreted in very different ways, representing everything from deities to the connection between heaven and earth. But why have these groupings of stars captured human imagination so profoundly? In ancient Greece, globular clusters were considered the eyes of the gods. Astronomers of that time, although lacking the instruments we have today, were able to distinguish some of these bright groupings in the night sky. They believed they were portals to the afterlife, places where the souls of heroes gathered. This fascination with the sky and its mysteries is a common thread in many cultures throughout history. For example, in Inca mythology, the sky was filled with stories, where each star had a meaning and purpose. Globular clusters, with their appearance of bright clouds, were interpreted as the abode of celestial beings. In Chinese culture, the constellation of the Pleiades, often confused with globular clusters, was seen as a symbol of abundance and prosperity. These groups of stars have inspired poems and tales that have been passed down through generations. The connection between humans and the stars has been fundamental in the construction of myths and legends, providing a sense of identity and purpose in life. As science advanced, so did our understanding of these astronomical phenomena. In the 17th century, Galileo Galilei was one of the first to observe globular clusters through his telescope, revealing the true nature of these groupings of stars. At that time, it began to be understood that these clouds were, in fact, dense collections of stars, each with its own life cycle and characteristics. However, the connection between these clusters and the stories told by ancient cultures was not lost. Instead, a new layer was added to our understanding. Globular clusters have also been considered in popular culture. In film and literature, they are often presented as symbols of mystery and exploration. Who hasn't dreamed of traveling through one of these clusters, discovering secrets of the universe that have remained hidden for centuries? Science fiction movies and books have used these images to create narratives that take us to distant and unknown places, evoking an innate curiosity about our place in the cosmos. In modern astronomy, globular clusters are more than just objects of study. They are key pieces that help scientists understand the history of our galaxies. Some contemporary myths have emerged around their formation and evolution, suggesting that they may hold clues about dark matter and the energy of the universe. These astronomical phenomena, once viewed only through the lens of mythology, are now the subject of complex scientific investigations. Reflecting on the relationship between globular clusters and culture, it becomes evident that these formations are not only crucial for astronomy, but also serve as a bridge between ancient and modern knowledge. The way we have interpreted these groupings of stars reflects our beliefs and aspirations from antiquity to the present day. The stories we tell about them help us understand not only the universe but also ourselves. Each culture has contributed its unique perspective on globular clusters, creating a rich tapestry of narratives that connect us. When we look up on a clear night, we can feel part of something larger, something that has been celebrated in myths and legends throughout history. Isn't it fascinating to think that, at some point, every star we see has been an object of admiration and speculation? Globular clusters, therefore, are much more than an astronomical phenomenon. They are a reminder of our relentless quest for knowledge and understanding. From ancient times to the space age, our desire to explore the unknown has remained constant. Every time we look up at the sky, we are connecting with generations of dreamers, scientists, and mythologists who have looked up in search of answers. In a world where science and mythology often seem to be at opposite ends, globular clusters show us that there is a space where both can coexist. They become a symbol of our shared curiosity and the desire to understand our place in the vast universe as we continue to explore and discover. The stories surrounding these stellar groupings will keep evolving, enriching both our science and our culture. Thus, at the end of the day, globular clusters can be seen as a metaphor for our own existence. A group of stars, each bright and unique, united in a cosmic dance. They remind us that, just like in a cluster, we are all interconnected in this vast and mysterious creation we call home. Research on globular clusters is an exciting field that continues to attract the attention of scientists and astronomers worldwide. But what makes these groups of stars so fascinating? Let's think of a globular cluster as an ancient cosmic library. Each star in this cluster is a book filled with stories about the universe and its evolution. By studying these clusters, astronomers can unravel secrets that help us understand not only the history of our galaxies, but also the history of the cosmos itself. One of the most prominent projects currently is the study of the globular cluster Omega Centauri. This cluster has become an object of interest because it has characteristics that set it apart from other typical globular clusters. Imagine a mystery that needs to be solved, and Omega Centauri is the key. Scientists are working hard to determine whether this cluster is actually the core of a dwarf galaxy that was absorbed by our Milky Way. By investigating its composition and structure, it is hoped that we can better understand how galaxies grow and evolve over time. Another interesting approach is the use of cutting-edge telescopes such as the Hubble Space Telescope and the James Webb Space Telescope. These instruments are like magical super lenses that allow us to observe the universe in unprecedented detail. Through them, researchers are gathering data on the age, composition, and dynamics of globular clusters. With each image they capture, they tell a part of the story of our universe, bringing us a little closer to understanding its antiquity and formation. Did you know that some recent studies have revealed that globular clusters could play a key role in the search for dark matter? This matter, which we cannot see directly, makes up a large part of the universe. Scientists have begun to observe how the gravity of globular clusters interacts with the surrounding dark matter. This is somewhat like observing how a fishing net behaves in the ocean. By studying the dynamics of these interactions, we might gain clues about the nature of this mysterious matter that constitutes most of the universe. As we advance in technology, new projects are also emerging that seek to study globular clusters in other galaxies. With the advent of more powerful telescopes, such as the Extremely Large Telescope, astronomers are eager to examine globular clusters in distant galaxies. This is comparable to exploring a new continent on an ancient map. Each cluster studied could provide valuable information about how different galaxies formed and evolved over time. Data collected by space missions such as the Gaia satellite are revolutionizing our understanding of the position and composition of globular clusters. Gaia acts as a cosmic detective, mapping millions of stars and helping scientists understand how globular clusters are distributed in our galaxy. This information is crucial as it allows us to build a more complete model of how the Milky Way formed and evolved. Astrobiology is also looking to globular clusters for answers. Although these dense regions of stars are not the most likely place to find life, their study can offer clues about the conditions that led to life in other parts of the universe. It's like investigating an ancient civilization to discover how ours arose. By unraveling the secrets of these stars, we could learn about the ingredients necessary for life on other worlds. Globular clusters are also of interest in the search for exoplanets. Although these clusters are not the usual place where habitable worlds are expected to be found, their study can offer new insights into how planetary systems form and evolve. Astronomers are using new techniques to detect planets in these unusual environments, which could expand our understanding of planetary diversity in the universe. As these investigations develop, the role of globular clusters in modern astronomy becomes increasingly crucial. Each discovery not only adds a piece to the puzzle of galactic evolution, but also generates new questions. It is an endless cycle of curiosity and discovery, where each answer leads to new uncertainties. Current projects are not only focused on observation, but also on simulation. Astronomers are using advanced computational models to recreate the evolution of globular clusters over billions of years. This is similar to making a movie where the actors are stars and the plot is the story of the universe. Through these simulations, phenomena that we have not yet observed can be predicted, opening the door to future research. The future of globular clusters in astronomical research looks bright, with many projects and collaborations underway. The interconnection of different disciplines such as physics, chemistry, and astronomy is enriching the field and providing new perspectives. This collaboration is vital as the study of globular clusters not only teaches us about them but also about the nature of the universe as a whole. The importance of globular clusters in science is not limited to astronomy. The technology developed to study these clusters has led to advances in other fields such as particle physics and engineering. This demonstrates that knowledge gained in one field can have repercussions in others, creating a domino effect of discoveries. In concluding this section on current research projects, it is evident that globular clusters will continue to be a topic of great interest in the scientific community. With each new technological advancement and each new discovery, we come a little closer to solving the great mysteries of the universe. And so we continue to explore this cosmic library one book at a time, in search of answers to the deepest questions about our existence and the cosmos that surrounds us. What role do globular clusters play in our understanding of the universe? This is a fascinating question that has intrigued scientists and astronomy enthusiasts alike. These ancient groups of stars are not only witnesses to the history of the cosmos, but they have also driven significant advancements in modern astronomy. But how have they achieved this? The answer begins with their very nature. Globular clusters are like time capsules containing stars that have existed for billions of years. By studying these stars, astronomers can unravel the secrets of stellar evolution and galaxy formation. For example, by observing the different life stages of stars in a globular cluster, scientists can gain clues about how the first stars formed in the universe. In this sense, globular clusters are like fossils of astronomy, providing invaluable information about past epochs. What about their influence on cosmology? These clusters have been fundamental in understanding the distribution of matter in the universe. As scientists measure the gravity exerted by globular clusters, they can infer the amount of dark matter surrounding them. Dark matter, although invisible, makes up most of the universe's mass. In this context, globular clusters act as natural laboratories where this mysterious substance is studied. Moreover, their study has revolutionized our ideas about galaxy evolution. Globular clusters not only orbit galaxies like the Milky Way, but they also influence their evolution. By interacting with other stars and galactic structures, they can contribute to the formation of new stars or even the merging of galaxies. These types of interactions are vital for understanding how galaxies grow and change over time. Technology has also played a crucial role in advancing the study of globular clusters. With increasingly powerful telescopes such as the Hubble Space Telescope, researchers can observe these clusters with unprecedented clarity. This has allowed for the discovery of new clusters and detailed studies of their characteristics. Imagine being able to look through a time and space that were once completely dark. This is how these telescopes have transformed our view of the universe. In addition to telescopes, computer simulations have provided a new approach to understanding the dynamics of globular clusters. By recreating the conditions that existed in the early universe, scientists can test theories about how these clusters formed and evolved. It's like having a cosmic laboratory where the laws of physics can be experimented with in a context that cannot be directly observed. But what about the future? The study of globular clusters is far from over. With the next generation of telescopes and space probes, even more astonishing discoveries are anticipated. These new instruments are expected to allow us to delve deeper into the mysteries of dark matter and dark energy, elements that remain largely unknown. The future of globular cluster research is bright and full of possibilities. In the academic realm, globular clusters have fostered international collaboration. Astronomers from around the world come together to share data and discoveries, creating a global network of knowledge. This exchange of information not only enriches science but also fosters a sense of community among scientists pursuing the same truth about the universe. The fascination with globular clusters has also permeated popular culture. Movies, books, and documentaries have explored their beauty and mystery, inspiring new generations to look up at the sky and ponder our place in the cosmos. In this way, globular clusters have not only impacted science but have also fueled the collective imagination of humanity. The importance of globular clusters in modern astronomy cannot be overstated. From their role in understanding stellar evolution to their influence on galaxy formation and dark matter, these groups of stars are fundamental to the advancement of astronomical knowledge. Each new discovery about them adds another piece to the puzzle of how the universe works. In summary, globular clusters are much more than just groupings of ancient stars. They are windows into the past, tools for understanding dark matter, and catalysts for galactic evolution. As we continue to explore their secrets, it becomes evident that the study of these clusters is not only crucial for astronomy, but also for our understanding of the cosmos as a whole. Looking to the future, we realize that every answer we find about globular clusters generates new questions. What mysteries still await us in the darkness of space? The quest for knowledge never stops, and globular clusters will continue to be a beacon guiding astronomers on their journey through the vast universe. Each star in a cluster is a reminder that, in the grand scheme of things, there is still much to discover. Have you ever wondered what the future holds for globular clusters? These fascinating conglomerates of stars have been a constant subject of study in astronomy, and their relevance does not seem to diminish over time. On the contrary, as we advance in our understanding of the cosmos, globular clusters are gaining new prominence, as if they are pieces of a cosmic puzzle that we are still trying to complete. Firstly, it is crucial to understand that globular clusters are like time capsules, preserving information about the early stages of galaxy formation. By studying their composition and dynamics, scientists can unravel the mysteries of how our universe was formed. Can you imagine being able to look back in time and discover the secrets of the past? That is precisely what researchers seek when studying these ancient groups of stars. An intriguing aspect is how technology is revolutionizing our ability to observe these clusters. With more powerful telescopes and satellites orbiting Earth, we are entering a new era of exploration. The data we collect today may change our understanding of how globular clusters move and evolve within galaxies. As we improve our tools, we also refine our questions. What other surprises await us in these ancient stellar groups? One of the most exciting topics regarding the future of globular clusters is their relationship with dark matter. This mysterious substance, which makes up most of the universe, remains an enigma. However, globular clusters could serve as valuable clues. Their behavior and distribution might help us understand how dark matter interacts with visible matter. As we delve deeper into this field, it is possible that each cluster becomes a window into the nature of dark matter. Could we be on the brink of a discovery that changes our understanding of the universe? Moreover, globular clusters can shed light on the formation of black holes. Some of these clusters appear to harbor massive black holes within them, raising fascinating questions about how these cosmic monsters develop and evolve. By studying the dynamics of globular clusters, astronomers are beginning to map out how black holes interact with their surroundings. Could these studies redefine what we know about gravity and space-time? The next decade will be crucial for globular cluster research. With the launch of next-generation telescopes such as the James Webb Space Telescope, we are about to obtain images and data never seen before. These technological advancements will not only allow us to observe globular clusters in other galaxies, but also provide the opportunity to compare and contrast different clusters throughout the universe. Each new finding could be another brick in the construction of our understanding of the cosmos. Additionally, scientists are beginning to see globular clusters as cosmic laboratories where stellar processes can be studied in action. How do stars form in environments so different from those we know in our own galaxy? What can they teach us about the initial conditions that led to star formation in the first place? The answers to these questions could revolutionize our understanding of astrophysics. In the realm of cosmology, globular clusters are starting to play a crucial role in our understanding of the origin and evolution of the universe. By observing how they are distributed and how they interact with other galactic structures, astronomers are building an increasingly clear picture of how galaxies formed and changed over time. Each cluster is a fragment of the cosmic puzzle that helps us understand the history of the universe. However, the future of globular clusters is not limited to academic research. They also impact our culture and our view of the cosmos. As we learn more about these ancient groups of stars, their magnificence and mystery can inspire new generations of astronomers, artists and thinkers. Who knows? Perhaps a child looking at the sky tonight will feel inspired to become the next great explorer of the universe. Our knowledge of globular clusters is constantly evolving, and each discovery raises more questions than answers. What secrets are still hidden from us? Human curiosity is insatiable, and it is that curiosity that drives us to look to the sky for answers. In each globular cluster, there is a story waiting to be told, and as we move into the future, each new finding could change our perception of the universe we inhabit. The next generation of astronomers will be responsible for continuing this exciting adventure. With the advancement of artificial intelligence and computer simulations, it will be possible to model and predict the behavior of globular clusters in ways that were previously unimaginable. Are we ready to see how these advancements transform our understanding of the cosmos? In summary, the future of globular clusters is bright and exciting. As we advance in our explorations, each cluster becomes a key to unraveling the mysteries of the universe. The story of globular clusters is a story of discovery, curiosity, and wonder. So the next time you look at the starry sky, remember that there is much more than meets the eye, and that each star shining in the darkness may be holding secrets that we have yet to uncover. Globular clusters are true jewels of the universe. Throughout this journey we have discovered their complexity, beauty, and the importance they hold in astronomy. But what do they really teach us about the cosmos? Why are they so essential for understanding our existence and the universe we inhabit? Let us reflect on their antiquity. Globular clusters are some of the oldest objects we know, with ages exceeding 10 billion years. This means they have been there, witnessing the birth and evolution of galaxies even before our own solar system existed. Imagine being a witness to the history of the universe, like a wise elder who has seen it all. Each star in a globular cluster is a fragment of that history, a tale of the formation of the first elements in the cosmos. Isn't it astonishing to think that these stars have withstood the passage of time and continue to shine like beacons in a sea of darkness? The relationship between globular clusters and galaxies is equally fascinating. They act as time capsules, preserving crucial information about galactic evolution. As we study these clusters, we can unravel the secrets of how galaxies formed and how they have changed over billions of years. What stories would they tell us if they could speak? What secrets of the cosmos are hidden in their dense cores? It is inevitable to wonder how globular clusters influence our understanding of dark matter. This mysterious substance, which makes up a large part of the universe, seems to be related to the formation and dynamics of these clusters. By studying how stars group together in a globular cluster, astronomers can gain clues about the distribution of dark matter in the universe. Could it be that these clusters are key to unraveling the mystery of what truly composes our cosmos? The observation of these clusters has also revolutionized our way of seeing the universe. With advanced telescopes and new technologies, we can now explore these distant objects like never before. Just as a detective uses special tools to solve a mystery, astronomers employ sophisticated instruments to discover the composition, age, and movements of globular clusters. What new revelations await us in the future as technology continues to advance? Culture and mythology have also found inspiration in these clusters. Throughout history, they have been a source of wonder and reverence. In various traditions, they have been seen as portals to the beyond, reminders of the connection between the divine and the earthly. How does this connection influence the way we perceive our place in the universe? As we look to the future, it is exciting to think about the impact that globular clusters will have on modern astronomy. Each study, each discovery brings us one step closer to understanding our own origins and the universe as a whole. What new theories will arise from the observations of these ancient groups of stars? The questions that arise are endless. How will globular clusters form in other corners of the universe? Could there be clusters that we have yet to detect? As we explore these possibilities, let us remember that each answer opens the door to new questions. This is the endless cycle of knowledge. The importance of globular clusters goes beyond what we can see. They teach us about matter, energy, time, and space. In each star, in each interaction, there are lessons about life and death in the cosmos. They remind us that, although we are small compared to the vast expanses of the universe, we are part of something grand and mysterious. So as we conclude this exploration, it is essential to pause and reflect. What have we learned about ourselves through the study of globular clusters? Perhaps they teach us that, like those ancient stars, we too are part of a vast and complicated web of existence. Each of us has a role in the history of the universe, even if it sometimes seems insignificant. In conclusion, globular clusters are more than just groupings of stars. They are windows to the past and guides for the future. They remind us that the universe is full of mysteries waiting to be discovered. The next time you look at the sky, remember that each point of light could be a story waiting to be told. After all, we are all explorers in this vast ocean of stars, and while the journey of discovery never ends, there is always something new to learn among the stars.